If I have a quadrilateral inscribed into a circle, now Ptolemy's theorem states that the sums of all of the product of opposite sides is equal to the product of the diagonals. If that's not that confusing, I'm going to assign some points. So A, B, C, and D. Ptolemy's theorem states that AB times CD plus BC times AD is equal to AC times BD. So AB times CD plus BC times AD is equal to AC times BD. So let's try this with an example. So let's say that AB is equal to 2, DC is equal to 13, BC is equal to 5, AD is equal to 6, and diagonal AC is equal to 7. Now, writing this, I realized that 2 plus 5 is equal to 7, and so this triangle is actually a straight line, and so this is not actually a quadrilateral, but hey, it's fine, we're gonna just ignore that. So 2 times 13 plus 5 times 6 is equal to 7 times BD. And so 26 plus 30 is equal to 7 times BD, 56 is equal to 7 times BD, and 8 is equal to BD. Now, as I mentioned earlier, triangle ABD cannot exist either because 2 plus 6 is equal to 8, and so we would also have another straight line. But hey, we're just going to ignore that and move on with some problems. And so our first problem's diagram is on the board, with the question now being right above it. Now, for the sake of avoiding very long calculations, I'm going to call AB is equal to BC is equal to CD is equal to 200, which is stated in the question. And we're going to set S to be equal to 200 to just avoid these long calculations. So also the radius of the circle is equal to S root 2. So first let's look at triangle BOC. Now since BC is equal to CD, that also means that CO splits BD into 2. BO is equal to S root 2 and so is CO. And so we can use Heron's formula to find the area of triangle BOC. The semi-perimeter is equal to S root 2 plus S root 2 plus S, all divided by 2. So now, applying this to Heron's formula, we get that the area is equal to S root 2 plus S over 2 times S over 2 times S over 2 times S root 2 minus S over 2. So then factoring out S over 2 and then applying difference of squares to these two terms, we get that this is equal to S over 2 times the square root of 2s squared minus s squared over 4. This is then equal to s over 2 times 7s squared over 4. This is then equal to s over 2 times root 7s over 2, which is equal to root 7s squared over 4. And now dividing by root s squared and multiplying by 2, we get that BD is equal to 2 times root 7 times s squared over 4 over root 2s. And so this is equal to root 7s squared over 2 over root 2s. This is finally equal to root 7 over 2 times s. And so BD is equal to root 7 over 2s. Now we can apply Ptolemy's theorem to ABCD, because from the question we want to find AD. And so, by Ptolemy's theorem, BD times AC is equal to BC times AD plus AB times CD. Now, BD is equal to AC, so we write BD squared is equal to BC times AD plus AB times CD. And now AB, BC, and CD are all equal to S. So BD squared is equal to S squared plus AD times S. Now BD squared is equal to 7 over 2 times S squared. We have 7 over 2 times S squared minus S squared is equal to AD times S. And so this is equal to 5 over 2 S squared is equal to AD times S. And finally, dividing both sides by S gives us 5 over 2S is equal to AD. And now since 200 is equal to S, we have 5 over 2 times 200 is equal to AD. And finally, AD is equal to 500. And so we are done. Alright, now on to the next problem. And so now our next problem is now above me. So first, let's draw point D, perpendicular to CB and passing through A. And so point D is over here. And so then we draw point E, which will be perpendicular this way. So point E. And lastly, we will draw point F from B. So F being over here. Now this is perpendicular, and this is perpendicular. So now what we're trying to solve for is DF. But now notice that since this is a right angle and this is also a right angle, ABDF is a cyclic quadrilateral. And so now all we need to solve for are BF, AD, AF, and BD. Now it is also pretty clear to see that triangles ABF, ADE, and ADC are all similar triangles. So now we can set up a system of equations. Let's set DB to be equal to x and AD to be equal to h, as I've already written here. So let's let CD be equal to 14 minus x. And so we have 14 minus x squared plus h squared is equal to 15 squared, which is equal to 225. We also know that x squared plus h squared is equal to 13 squared, which is equal to 169. And so now we get that 14 minus x squared is equal to 56. And so 196 minus 28x plus x squared minus x squared is equal to 56. Now these two x's cancel out, and rearranging terms, we get that 140 is equal to 28x, and x is equal to 5. And so now we see a 13, 5, 12 triangle, and so h is equal to 12 as well. Alternatively, you could substitute 5 into this equation and solve from there. So now 14 minus x is equal to 9. So we have a 15, 9, 12 triangle here as well. Now we know that ADC is a 3, 4, 5 triangle. So then we also know that AFB is a 3, 4, 5 triangle. And so AF is equal to 13 times 4 over 5. And also that BF is equal to 13 times 3 over 5. And so now by Ptolemy's, we know that BF times AD is equal to AF times BD plus AB times DF. And so we get 13 times 3 over 5 times 12 is equal to 5 times 13 times 4 over 5 plus 13 times DF. And so dividing everything by 13 gives us 3 over 5 times 12 is equal to 5 times 4 over 5 plus DF. And so 36 over 5 is equal to 4 plus DF. And so 16 over 5 is equal to DF. And since 16 and 5 are relatively prime, we know that 16 plus 5 is equal to 21, and that is our answer. And so that is our answer, and we are done. Alright, thanks for watching. Hopefully you enjoyed, and hopefully I'll see you next time.